Hello and welcome to Amateur Radio Topics. I'm Kevin, VK6 Lima Whiskey, and this is episode number 2. And in this episode we were going to take a look at feed lines and matching the antenna. So in the previous episode we took a look at wire dipoles, simple wire dipoles, fed in the centre with a low impedance feed line. Now most low impedance feed lines are 50 ohms. RG58 is a good example. Coaxial cable, inner centre conductor and an outer braid, around about 5mm diameter, quite lightweight, good for home installations, good for portable expeditions, and relatively cheap. The other alternative is RG213. This is much heavier duty, around about 10mm in diameter, and importantly it has less loss. It also has a higher power capability, so the RG58 is probably pretty good if you want to run maybe 400 to 600 watts output. The RG213 is better if you want to run higher power. But they both do the same job, except that they have different characteristics. And probably the biggest characteristic is the difference in the loss. RG213 has less loss, and also there's a difference in the price and a difference in the type of connectors that are used. But either coax is fine for getting your signal from your transceiver to your antenna. Now in an ideal world, the impedance at the centre of the antenna will be 50 ohms. And the coaxial cable has an impedance of 50 ohms. So in those circumstances you would have an SWR of 1:1. And when you plug your coax into the output of your transceiver, you'll have a 1:1 SWR. If you have a situation where the antenna has an impedance other than 50 ohms, and this is quite common, maybe 60 ohms, 70 ohms, 100 ohms, or maybe it will have capacitive reactance or inductive reactance at the centre, all of which can be brought about by proximity to trees, masts, towers, houses, irregular shaped antenna, then you may not have an SWR of 1:1. Because the impedance at the centre of the antenna may not be 50 ohms. So this is where the ATU that's in your transceiver has a role to play. Now the ATU doesn't really tune your antenna. That's probably not an accurate description. It matches the feed line, the complex impedance at the end of the feed line to your transceiver and keeps your transceiver happy, keeps the transistors in the final running cool and prevents them from shutting down due to a high SWR. That's all that it is doing. And most ATUs or matching units in transceivers will match complex impedances from something like 60 ohms up to maybe 300 ohms on the coax line. So this gives you quite a bit of flexibility. There is a loss associated with the coax itself, and the loss figure varies according to the frequency. So the lower the frequency, the lower the loss per meter. And as you increase in frequency, you lose more dBs per meter. Now on the lower bands, on 160, 80, 40 meters, this is pretty negligible. It really starts to become more of an issue maybe on 15 to 10 meters if you've got long runs of coax. And if you have a long run of coax, this is the other motivation to use the RG213. Because the RG213 is bigger, it has less loss, and so consequently for a longer run of coax on the HF bands, particularly the higher bands, 15 and 10 meters, it makes a difference, or it can make a difference. There is also a loss associated with the SWR. So if you have an SWR of 1:1, you only have to worry about the loss that is inherent in the coaxial cable. If you have an SWR of 1.5:1 or 2:1 or 2.5 or 3:1, then there is a loss associated also with the SWR, which needs to be added to the loss of the cable itself. Now, the loss on the SWR is not that great. It's not a huge amount of dBs, but it does depend again on the frequency, and it will vary according to whether or not it's a low frequency or a high frequency. But generally speaking, if you put an antenna up, broadly speaking, and it has an SWR somewhere around about 2.5 to 1, and you can adequately match that with your ATU that's embedded into your transceiver or even an outboard ATU, then this is going to be okay. You're not going to have a problem with the performance of the antenna. It's not going to really be noticeable at the other end. And the SWR on the feed line does not change the characteristics of the antenna at all. So it doesn't change the radiation pattern. It doesn't change anything about the antenna. It just has an effect, obviously, on the ability of the transceiver to match the complex impedance that it sees at the end of the coax. Now, if you decide that you want to use 75 ohm TV coax, this is absolutely fine. This works really quite well. It has a diameter of about 7 millimeters. It's in plentiful supply. It's very economical to purchase. It can be terminated with standard PL259 type connectors. It just needs a little bit more care to do so. And this is a good choice because it's still fairly lightweight. It's got good power handling capability. It's slightly bigger than the RG58 and it has less loss. And the difference at the antenna feed point is going to be negligible. Your antenna feed point is most likely, with a dipole, depending on the height above ground, to be somewhere between maybe 35 ohms impedance and maybe up to 80 or 90 ohms impedance. Could be anywhere in that range. But essentially, it's still a low impedance feed point. It's not a high impedance for a normal half-wave dipole. So the 75 ohm TV coax, actually a really good choice. And I've used this quite successfully on many HF antennas. I've also used it on my receiving beverage antennas, and it works very well there. And it's not something that should be dismissed just because it's not 50 ohms. On the HF bands, that's really not going to make any difference. So the other aspect to matching antennas, or matching the coax of the antenna to your transceiver, is whether or not you are considering using an open wire line feeder. Now things get a little bit more complicated. If you use open wire line, then that's great. You can run open wire line to any dipole antenna. You just have to think carefully about what's going to happen at the other end of the open wire line and what sort of impedance you would normally see. And most transceivers on the market cannot match an open wire line to their output without maybe some form of a 4-to-1 balun, for example. And again, we'll cover these in a little bit more detail in future episodes. Or a more complex antenna tuning unit, which is normally an outboard unit, which has the ability to handle open wire line and transform that impedance down to 50 ohms for the transceiver. Open wire lines has many advantages if you want to build a multiband antenna. And this is something that we will discuss. The multiband antennas, it's very difficult, as I mentioned in the previous episode, to get a multiband antenna that is efficient on every single band. That's not going to be possible. But they're normally adequate on all bands and quite good on maybe 2 or 3 out of maybe the 7 or 8 on offer. A lot of the multiband antennas are fed with open wire feeder, and there's a really good reason for this. And that is because with open wire feeder, you can tolerate a high SWR on the open wire line at a very low loss. But open wire feeder is not so easy to feed into the shack, for example. It's not easy to get it into the shack. There's some difficulties associated with running it through. You can't bury it. You can't run it next to the tower. There's a whole range of reasons why people tend to shy away from open wire line a little bit. And one quite common way of dealing with open wire line is to have an open wire line feeding a center fed dipole and run the open wire line down to the antenna tuning unit, which then sits in a remote location. Then the coaxial cable runs back to the shack into your transceiver. And the antenna tuning unit that sits at the base of the tower, the mast or the tree is remotely controlled. And that's actually quite a good solution. That works quite well. It will give you multiband capability and it can be used very flexibly with a number of solutions for multiband antennas. Multiband antennas, there's no real secret to them. There's various designs that are published that use certain dimensions and characteristics, but virtually any dipole fed at the center with open wire line will work on multiples of the resonant frequency. So for example, if you had an 80 meter dipole, which is around about 130 feet long or around about 40 meters length, and you fed that in the center with open wire line having a characteristic impedance of 450 ohms or 600 ohms, then that antenna could be used on 80, 40, 20, 15 and 10 meters quite happily with the appropriate antenna tuning unit at the base of the tower or mast, open wire line feeding into that, and a coaxial run back to the shack. That arrangement will work perfectly, and it's what many people use. It's commonly referred to as, in that case, an 80 meter doublet. Now, there are other multiband antennas that use a fixed length of open wire line and then straight into coaxial cable. And they also work quite well. There are some constraints with this type of antenna, mainly because having a fixed length of open wire line that then feeds straight into a low impedance coax means that really only on maybe 2 or 3 of the bands have you got a reasonable match. However, it doesn't stop the antenna from working, and these antennas can be used quite successfully, particularly if you can get the antenna up into the clear, get it fairly high up. It normally has fairly omnidirectional radiation pattern on the HF bands, and on the lower bands such as 40 and 80 meters, that type of antenna will have probably more of a pattern very similar to a traditional dipole. So these are worth considering, and we can certainly examine these multiband antennas in a little more detail moving forward. The other thing that maybe I wanted to just touch on was that with a dipole antenna that's fed straight into a low impedance coax, it's quite advisable to consider maybe a coaxial choke at the feed point. Now, a coaxial choke is not really a balun. It's more of a way to stop the RF flowing down the outside of the coaxial cable. And there's a number of reasons why this may be desirable. It doesn't really change the impedance match, but it does mean that the antenna becomes a little bit more balanced. And for a lot of dipoles, particularly on the lower bands, maybe 80 and 40, this is maybe not such a big problem. It becomes more of a problem as you go higher in frequency, and it certainly becomes a problem if you're trying to design a multi-element beam with a driven element fed with coaxial cable. You want to try and keep the beam as balanced as possible so that the radiation pattern is nice and clean. Now, a coaxial choke is simply a coil of coax that's wound on maybe a 4 to 5 inch diameter, around about 100 millimeters diameter PVC pipe, and the number of turns varies according to the frequency. So if you wanted to put up, say, a 20 meter dipole, and you would like to put a coaxial choke at the feed point, it means that you would coil the coax at the feed point, and you would have maybe around about 6 turns of coax on 100 millimeter diameter PVC pipe. And that's it. It's really simple. There's no ferrites involved. There's nothing else. Now, if you use the same arrangement on 40 meters, the same coil would need to be around about 12 turns on 40 meters. And of course, then you go to 80 meters and the same coil would need to be around about 24 turns, and so on. I've used these coaxial choke type arrangements on multi-element beams. They work quite well. And I've successfully used something that's around about 5 turns, and it adequately covers 20 meters, 15 meters and 10 meters. And it just gives the coax a little bit more chance of being isolated from the antenna in terms of RF current that may flow down the outer. Now, this does help. It helps with the, as I say, the radiation pattern on a beam. On a dipole, the effect is actually probably negligible. If you choose not to put that coaxial choke in there, it won't really have any ill effects. It can help in some situations where maybe you have an OFI problem, or you have maybe a TVI problem, to try and isolate that coaxial braid from the antenna. And there are other ways to do it. You can use a ferrite ballon or a ferrite choke at the feed point, and this can either be a ferrite ring with a number of turns of coax distributed around the perimeter, or it can be ferrite beads which are slipped over the coax and they perform the same action. Now, the ferrites work perfectly okay. I've used them on many occasions. The only time you need to be perhaps careful with a ferrite is sometimes with high power. They can become saturated, and this can lead to a whole range of problems that you don't really want to have. So personally, I find that if you can use an air cord coaxial choke, this is the simplest option to isolate the feed line from the antenna. So this concludes episode 2, feed lines and matching the antenna. And in the next episode, we will take a look at the multiband antennas in a bit more detail, and also wire beams, which can be easily constructed using the same methods we have discussed so far. Notes about this episode can be found on our website, zigzagwest.com, or you can contact us via hamradiotopics@gmail.com. 73s from Kevin, VK6 Lima Whiskey.